Assalamualaikum. How to identify oxidizing and reducing agent. For the identifying of reducing agent, following steps must be understood and must be observed in the answer of the question. For example, the first thing that must be written onto the chemical equation or somehow or the other are the oxidation states. Of each atom present both in the reactants as well as in the products. The second step is the identification of where the oxidation is taking place and where is the reduction taking place. Third step is to literally identify or point out the oxidizing agent, which is the compound or molecule, or as a whole you can call a substance, in which any one or two are undergoing reduction. Similarly, pointing out the reducing agent, which is a substance in which any one or two atom are under, basically most of the time it is only one atom which is going on, in which the oxidation is taking place. Now the question arises how to give the oxidation states to the chemicals which are present. For example, let's give an example: Fe2O3 plus CO 2Fe plus 3CO2. For this you must know the rules for assigning oxidation states. Now what are the rules? Any free element will have, free or uncombined element will have the oxidation state 0. For example, in this whole equation, Fe is a free or uncombined. Free means it is not making any molecule, or uncombined means there is no other element for the combination. Done. Second is, for example, for group A elements of the oxidation state, for the group A elements would be given according to their group number. For example, for group 1, 2, 3, the oxidation states are +1, +2, +3. For group 5, 6 and 7, the oxidation states are -3, -2, -1. And for group 4, it must be calculated by the process, and they may be +1 or -4, +4, -4. For group 4, as well as for the group B elements, all of them, the oxidation states are found by the formula. For group B elements, for the oxidation states are calculated by the formula in which we have studied that the total oxidation state of a compound is 0. For example, in this chemical equation, if I will write the oxidation state of group A elements, oxygen belongs to group 6, which will I know from the atomic number which would be given in the question sheet. So it is group 6, so the oxidation state is -2. Here again group 6, the oxidation state is -2, here 0, here -2. Then carbon belongs to group 4, we will find out the formula from this process, and Fe also belongs to group B element, so we will find out the oxidation state by this process. For example, Fe2O3 is equals to 0. The oxidation state, total oxidation state of the compound is 0. So the chemical formula would become like this: 2Fe plus 3O is equals to 0. 2Fe plus 3 minus 2 is equals to 0, which will ultimately goes as 2Fe plus minus 6 is equals to 0. 2Fe plus minus minus, and it would go to that side, it would become plus 6, or Fe would be equal to 6 plus divided by 2 plus 3. So we will write down plus 3 here. The other way is to find out from the corresponding. For example, this is 3, so this oxidation state belongs to this, and we will have a plus because this is a metal. This oxidation belongs to this, and we will have a minus because it is a non-metal. The other way, for example, CO, we cannot have any oxidation state beneath this compound or something like that. We can calculate in the same way. CO is equals to 0. So C plus minus 2 is equals to 0. So C would be equal to plus 2. Here the oxidation state is plus 2. For CO2, we will have CO2, C plus 2 minus 2 is equals to 0. So it will become C is equals to plus 4 after calculating. So ultimately we will have plus 4 here. After writing the oxidation state, now we have to identify oxidation and reduction, where the oxidation is taking place and where the reduction is taking place. For this, we have to monitor each of them. Those atoms where oxidation state is not changing in reactant and product must be ignored. For example, if you see, the oxidation state of oxygen in all of them is minus 2. For the other atoms, for example, the oxidation state of iron is reducing here in the reactants. So oxidation state plus 3 reduces to oxidation state 0. It means as the oxidation state is reducing, this is the reduction. So we will write reduction. Why? Because of decrease in oxidation state. Similarly, if you look at here, from plus 2 to plus 4, the oxidation state is increasing. So we will write oxidation, and then in the bracket we will write down the reason. The reason is increase in oxidation state. So after that we will write down what is happening, a reducing agent or a oxidizing agent or an oxidizing agent. As Fe, not all of them, the only one element of the compound is reducing, hence this is an oxidizing agent. The whole compound is an oxidizing agent. This must be kept in mind. As C is increasing its oxidation state, it is an reducing agent. Now as a conclusion, you have to write, after this is the part of your, this is all the understanding parts, this is the part of your answer. Write down the chemical equation like this, write down which is reducing, write down the oxidation state like this, write down which is reducing and which is oxidizing, and then write down the oxidizing and reducing agent in such a way, and after that give a conclusion at the end of your answer. The conclusion is Fe2O3, the whole compound is an oxidizing or reducing agent, is an oxidizing agent. Similarly, CO, the whole compound is a reducing agent. Do not write a single element of that compound. The whole, always remember, oxidizing agents and reducing agent belongs to only the reactants. Number 2, the oxidizing and reducing agents are the whole compounds, not the individual elements present in that particular compound. Understood? I hope this video is helpful for you so that you could prepare the topic of identification of oxidizing and reducing agent. Thank you.